Welcome, and thank you for listening to this Paragon Edge audio blog. Modern ATMs are no longer simple cash dispensers. Advanced function ATMs now operate as software platforms at the edge, integrating cash recyclers, deposit imaging, biometrics, fraud services, contactless kernels, and network-driven logic through CEN XFS services. As this complexity has grown, a subtle but critical issue has emerged: XFS fragmentation. What was once a manageable development concern has become a deployment and operational risk, especially for large North American ATM fleets running mixed hardware, multiple middleware stacks, and varying XFS versions. XFS fragmentation occurs when an ATM estate contains multiple CN XFS versions, vendor-specific XFS extensions, different OEM hardware combinations, peripheral firmware, and driver mismatches, and inconsistent service behavior across environments. These variations create subtle differences in how services respond and interact, which can introduce unexpected behavior across the ATM fleet. In advanced function environments, these differences matter because ATMs are stateless at the application level. Business logic depends on the real-time behavior of XFS services, not predefined states and screens. A small change in one service, such as a recycler, deposit module, or card reader, can have unintended downstream effects across the entire transaction flow. Several forces are amplifying the impact of fragmentation. One major factor is fleet modernization without peripheral replacement. Many institutions are refreshing operating systems and middleware while retaining older peripherals, creating hybrid environments where different generations of hardware and software must interact. The result is a service matrix that rarely matches the simplified assumptions found in test labs. Advanced function growth. Deposits, recycling, assisted service, and personalization all rely on tightly coordinated XFS services. Fragmentation increases the probability of workflow-level failures, not just device errors. Late-stage failure discovery. Traditional test environments often fail to represent the exact XFS service combinations found in production. Issues surface during UAT or pilot, when fixes are slow, visible, and costly. In short, fragmentation no longer slows development. It threatens rollout timelines, service availability, and operational confidence. In reality, production fleets contain dozens or even hundreds of service variations. It is very difficult for traditional lab testing models to scale appropriately in order to represent this diversity, and manual testing alone can no longer keep pace with OS updates, middleware changes, and compliance events. This is where many ATM deployments run into trouble. Not because the application logic is wrong, but because the service behavior was never truly tested. Paragon's virtual ATM platform is purpose-built to address this problem by shifting testing from hardware-dependent assumptions to service-level realism. Virtual ATM simulates real XFS services, cash handling, deposits, card readers, PIN pads, and more, allowing teams to test against production-like service behavior without physical devices. This makes it possible to validate mixed XFS versions, vendor-specific extensions, peripheral behavior differences, and error conditions that are difficult to reproduce in traditional lab environments. Rather than testing isolated messages, virtual ATM enables end-to-end workflow validation across interacting services. Teams can observe how changes in one XFS service affect downstream flows before deployment. Virtual environments allow deployers to test multiple configurations in parallel, dramatically increasing coverage without expanding hardware labs. This capability is critical when rolling out OS updates, middleware upgrades, peripheral firmware changes, or new advanced function features, where even small changes can affect how XFS services behave across the ATM environment. One of the most important benefits of virtual ATM is not testing speed, it's testing fidelity. Advanced function ATM deployers no longer need to guess whether their test environment matches production. They can model the real XFS service matrix found in the field and validate behavior before issues reach pilots or customers. This transforms XFS fragmentation from an unpredictable risk into a manageable engineering variable. XFS fragmentation is no longer just developer inconvenience. It has become a deployment-level risk that can delay rollouts, trigger operational exceptions, increase InfoSec and compliance escalations, and undermine confidence in advanced function features. By using virtual ATM to virtualize XFS services, automate regression testing, and validate real world service interactions, deployers can detect fragmentation related issues earlier, reduce reliance on scarce physical hardware, scale testing without scaling manpower, and deliver advanced function features with greater confidence. In a world where ATMs increasingly operate as software platforms, testing the service layer is no longer optional. It's essential. Thank you for listening today.